Okay, this is lecture 8. We will talk about measurement. Okay. We already know that we need to operationalize a concept in order to conduct any research on that concept. So when you operationalize it, it creates variable. The variable needs to be measured. And so that means variable is a measurement, and some measurement is better than others. So therefore, we need to come up with a way to evaluate and talk about what measures are better than other measures. That's the issue that we are going to talk about. So we talk about 3 different issues related to measurement. Number 1 is something called validity, or more specifically, it's called construct validity. So we talk about what is it, how is it actually measured. So this is actually not about a measurement, how validity is measured, and how is this going to affect your research. Also, we talk about reliability. What is it, and how is it measured, and how is this going to affect your research. And then finally, we are going to recap some of the topics from statistics, namely different scales of measurement. So what is construct validity? The construct validity is the degree to which specific measurement accurately measure what you want to measure. So construct validity is whether or not the measurement is actually measuring what you want to measure. Okay, so let's talk about this using an example. Okay, Wechsler Adult Intelligence Scale, or WAIS, is believed to have relatively high construct validity for measuring intelligence. This is because WAIS tests various intelligence-related concepts based on empirical finding, and it's related to many different kinds of performances that's supposed to be related to intelligence. On the other hand, phrenology, like size and shape of people's head, has a low construct validity because it's not measuring what it's supposed to measure, which is intelligence. So construct validity is a sort of grand theme of validity, and that's based on many more specific measurement of validity. So construct validity cannot be directly measured. So it needs to be kind of assessed using more specific kinds of different kinds of validity. That's what we are going to talk about in the next slide. So these specific attributes of validity that contribute to strength of overall construct validity that we talk about in this class is face validity, content validity, predictive validity, concurrent validity, convergent validity, and discriminant validity. So there are a lot. Okay, so the face validity is the simplest. Whether the measure appears to measure what it's supposed to be measuring. So today, phrenology, which is actually what we talked about, the head size, seems to have a low face validity because we know that head size is not related to people's mental ability, namely intelligence. So face validity is useful as an initial judge of measures validity. So to be more specific, in order to have a construct validity, it needs to pass the test of face validity. But passing the test of face validity is not sufficient for the overall construct validity because it needs to pass many more specific tests of validity, which we are going to talk about. The content validity refers to whether the content of the measure reflects larger body of the universe of the concept of your interest. For example, think about depression. Depression has a lot of different kinds of attributes such as tiredness, lack of sleep, sadness, anxiety, and many different kinds of things. So therefore, depression cannot be assessed with just single question, asking about single things. So in order to have a content validity, this means the depression measure needs to cover all these universe of depression. And to the extent that your entire measurement, like questionnaire, covers all these universe of depression, it's said to have a high content validity. Predictive validity is whether the measurement predicts the expected outcome. For example, if a measure has a validity, it should predict the outcome relevant to the behavior being measured. For example, intelligence test should predict academic performance. Okay. Concurrent validity is somewhat similar to predictive validity, whether a new measure is positively correlated with existing measure. So here now the frame is a little different from predictive validity. Now you are interested in, or you came up with this new measurement, and you want to establish the validity of that new measurement that you're going to use now, you made, for example. In order to do that, you need to correlate that with existing measure that is confirmed to have high validity. And if that has a high positive relation between the new measure that you're interested in and established measure, it's said to have a high concurrent validity. Conversion validity is also somewhat similar to concurrent validity and predictive validity. Whether there is a strong correlation between the scores of two or more tests that are measured to measure the same construct. So first, you have a bunch of different kinds of measure that you already know to measure some important constructs such as intelligence, such as, for example, SAT verbal, SAT mathematics, and academic performance. And if the new intelligence test that you are interested in is positively correlated with all these different kinds of measures that show conversion validity, because it convergently supports the validity of the new measurement that you are interested in. That's the conversion validity. Okay, so now discriminant validity. Okay, whether discriminant validity refers to whether the outcome of the measure is not related to any variable that it should not be related to. For example, depression should be related to depression, but it should not be related to schizophrenia. Because depression, so that means the measure discriminate schizophrenia and depression. That's what discriminant validity is. And one important thing that you need to note is this is somewhat negatively related, complex negative relation with content validity. Note that content validity, recall that is related to the kind of coverage of the universe. So initially, when you increase the coverage of the universe of depression, it shouldn't affect discriminant validity. However, if you become overly kind of inclusive about all these other concepts that may be related to depression, but not directly related to depression, you start contaminating the measure of depression. Therefore, your discriminant validity of the measure as a measure of depression gets compromised. Hope this makes sense. Okay. So that issue about the relation between content validity and discriminant validity is actually captured, or I try to illustrate using this diagram. Like intelligence test should somewhat related to general knowledge, SAT mathematical, SAT reading ability, but should not be related to emotional stability. Okay, so to be kind of more concrete, so discriminant relation between discriminant validity, importance of discriminant validity and content validity in determining and contribution to construct validity is you need to get the sweet spot. That means it needs to have enough coverage, but the coverage should not be so general that it's specific to the measure that you're interested in. So similar concept is a recall and precision here. I'm not going to get into too much deep into this, but please read the slide carefully. I'm not going to ask you about this in the exam, but it's useful concept that's related to recall, and precision is related to the relation between content validity and also discriminant validity. Now we are moving on to issue that's related to reliability. Issue of reliability occur because when you measure anything, the measurement contains both what we believe to be true score and error. So let's look at this the table. Okay, so there is a test A and test B. Okay, and there's a score has a variability. As you can see, test B has more variability, but let's assume that both of them are measuring IQ, and then you already know IQ is known to be or believed to be assumed to be stable. So that means, if let's say my IQ is 100, then my IQ should be 100 tomorrow. My IQ should be 100 day after tomorrow. So therefore, my IQ score should not vary too much. So the amount of variability that happens to my IQ test score should be understood as caused by errors. So therefore, the measurement score that you actually observe, such as in this case, 100, 99, 100, 101, 99, 100, 101 for test A, 93, 100, 700, 100, 700, and 93 contains both true score and error, and to the extent that you believe measurement or logic assumes that true score doesn't change, but error changes because of different situations. Therefore, variability is due to inconsistency of the score is due to error. So the larger the error, the more inconsistent. Okay, so that's contribute to the reliability. Amount of error varies with the measurement tool. That's the degrees of reliability. So the definition of reliability is consistency or stability of a measure. When the measure is reliable, it produces the results that's basically consistent for the same person across multiple attempts. There are many different kinds of reliability because you have different kinds of research situations. So we talk about different kinds of reliability and how they are actually measured. Okay. So different types of reliability. 3 different kinds we're going to talk. Okay. So number 1 is test-retest reliability. The same person are tested twice on the same test, then the score should be the same. So that's the test-retest. So it's a consistency of the same test about the same person across 2 or more different situations or time. That's the test-retest. Inter-rater reliability is very important in observational research. So this is an extent to which 2 or more observers score, code, or interpret the same data in the same way. This is important because in many observational research, you observe, for example, a person's emotion. An emotional state of a person who is observed needs to be interpreted. If the person A, I'm the researcher, person B, you are the researcher, interpret the person's emotion as different, that means it's not reliable. Okay, so therefore inter-rater reliability needs to be measured, and this is usually measured using the index called Cohen's-Kappa. Okay, and then finally internal consistency reliability, which is a little complicated. So I'm going to move on to the next slide to explain this. Okay, internal consistency reliability is measured using Cronbach's alpha or item total correlation, which is also known as point-wise radial correlation. So the definition of this is the extent to which individual item in a test consistently measure the same content or same content. So this means, for example, let's say that you are measuring depression and you believe depression to be integral and the consistent and coherent construct. Then you can, because of the content validity issue that we talked about, you can have one question, but you need to have 20, 30, 40 questions to assess person's depression. Then the implication of this is these 40 questions included in your questionnaire needs to be equally measuring depression, even though it's measuring different aspects. And to the extent depression is a coherent construct, all these measures should be consistently positively related. Okay, so this means if overall score is high, then each individual scores measured by each individual question should be also high. So this means overall mathematically, there should be overall high consistency or high positive correlation between individual score and overall score. Okay, so that is the internal consistency reliability. And for item total correlation, so let's look at the actual computation by looking at the next slide. So actual computation of item total correlation or point biserial correlation is, let's say you compare two people. The person X gets item 10 correct. Person Y gets item 10 incorrect. Which one of them should have an overall higher score? Then the answer should be the person X, because the reason is because the person X gets item 10 correct. So this means the person knows this construct. Therefore, if all of these items in that test is measuring the same construct, the person X should get a higher score because it's consistently measuring the same item. Okay, so the extreme case is going to be, let's think about exam. So exam has this one question where the person with the highest score gets this question wrong, but the person with the lowest score gets this question right. In that case, this doesn't make sense because higher knowledge, high performing students get the answer wrong, question wrong, but lowest score, lowest performing person gets this question right. That means it's possible this question is measuring something it's supposed not to measure in this test. That's the item total correlation or internal consistency measure attempt to measure as a reliability measure. So, please, because this is a complicated concept, it may take some time for you to get it. So please read this part carefully. Okay. And inter-rater reliability we already talked about. Observational study, inter-rater reliability is very important. It's usually indicated by the percentage of agreement of the interpretation across two or more individuals. And also more sophisticated measure is Cohen's kappa. Okay. Relation between reliability and validity. Number one, reliability tells us only about consistency, and reliability does not tell us whether the measurement tool adequately measuring what you're supposed to measure. So therefore, it's possible high reliability and a low validity. In that case, measure is consistently wrong. So let's think about a head size or shoe size. Let's say you are claiming shoe size is going to measure the person's intelligence. Shoe size doesn't change, therefore reliable. But it's reliably wrong as a measure of intelligence because it doesn't measure intelligence. Okay, so what about the other side? Whether or not high validity means reliability, that's a very complicated question. And pursuing this question requires you take more specialized courses in the graduate level. So I'm not going to get into that issue. Okay, measurement scale. This is a recap. So please recall there is a nominal scale, ordinal scale, and interval scale and ratio scale. Nominal is basically simply nominate, and it's a categorical, but it doesn't carry any quantitative meaning. Male versus female is nominal scale. Ordinal scale has ordered properties such as, for example, movie rating. 4-star movie is better than 3-star movie, but the difference between 4-star and 3-star is not the same as 3 stars and 2 stars. Therefore, the distance cannot be trusted. Okay. Interval scale, the difference between the numbers rank of the scale is meaningful, and therefore it's a consistent. Temperature scale on thermometer is interval scale. Okay. And ratio scale is an interval scale, but also you can trust the 0 as an absolute 0, and below which the scale cannot happen. So example is your weight. 40 pounds is twice as heavy as 20 pounds because the distance from 0 to 40 is twice as large as the distance between 0 and 20. An important point about choosing a measure is also there is an extra issue that you get introduced here is reactivity. When you actually measure, people react to the measure. The most, for example, let's say that you're taking intelligence test. You get stressed or you get anxious. It tends to undermine or negatively affect performance on some people. Whereas people who get used to take intelligence tests, maybe it's going to fire up and it may positively affect. Both of these examples actually suggest reactivity. The measurement opportunity is going to influence the measurement itself. That actually compromise reliability because it's actually error component in the measurement. Okay, so that's the issue about the reactivity. Okay, so important. Let me see. So here is an example about the reactive measure. So please read it carefully. And so you need to think about if you suspect the measure has a reactivity, you need to think about the way to overcome it. This slide talks about some way to overcome that. Okay. An important point about scale of measurement is, okay, so let's organize it. You use a variable to operationalize a concept such as intelligence, attitude, and you are interested in. Scale is the property of the variable you use. So when you operationalize it, you need to choose a particular scale. And then the scale of your variable affects the interpretation of your results because the different scale carry different amounts of information. For example, nominal is very about because it's not quantitatively precise, whereas ratio scale is most precise. And this also that you need to consider when you think about this in the context of psychology measure. Many people treat some Likert scale like interval scale, but is it really Likert scale? That's a complex issue that you need to continue to think in psychology. And then limitation of interpretability based on different kinds of scales. Nominal scale does not contain any quantitative information. Ordinal scale carries some quantitative information. Interval and ratio scales both carry quantitative information, so you can make quantitative argument based on numerical and statistical data.